Okay, so in this second part of our lecture, the definition that we are going to discuss naman is all about the definition of Bronsted and Lowry. So we have here Bronsted and Lowry. Okay, review muna tayo. Again, sabi natin, kapag daw acid, according to early news, in reaction with water is the one with will produce hydronium. Correct. And kapag naman base is the one that will produce hydroxide. Correct. Now, how about the definition of Bronsted and Lowry? Okay? So, medyo kakaiba naman to because wala nang involvement of water no, to produce hydronium at water to produce hydroxide. The definition of Bronsted and Lowry is based on an acid is a proton donor and a base is a proton acceptor. Okay? So according to Bronsted and Lowry, acid is the one that donates proton and base is the one that accepts proton. Okay? And according to Bronsted and Lowry, we have what we call the acid-base reaction. The acid-base reaction. Like what I've told you, no, an acid-base reaction is an example of, correct, double displacement reaction. Okay. Now, acid-base reaction is simply a proton transfer reaction. So, bakit siya naging proton transfer reaction? Acid-base. Acid gives proton, no? Base accepts proton. So, transfer lang. May nagbigay, merong tumanggap. May tumanggap, merong nawalan. For example, we have acetic acid, which is an acid. Okay, so where is our pen? Acetic acid, CH3COOH, which is our acid, plus ammonia, which is our base. Okay, what will be the product of this one? So, meron daw mag-donate ng proton. Sino yung mag-donate ng proton? Si acid. Okay? So, acid, this is our acid. Ang gagawin ni acid, donates proton. No? Ito yung base natin. Ano daw yung ginagawa ni base? Accepts proton. Ibig sabihin, a while ago, no, in our previous video, we discussed that acetic acid is an example of a weak acid because it can only lose one hydrogen. So this hydrogen will be donated by our acid. Who will accept this hydrogen? Correct. Our base. Thus, it will produce ammonium ion and our acetate. According also to Bronsted and Lowry, we have what we call conjugate base and conjugate acid. Okay? These pairs are pair of molecules or ions that can be intercovenanted by the transfer of protons. So in this case, kapag po sinabi nating conjugate acid, siya po yung ating formerly base who accepts the proton. Therefore, ammonium ion as our conjugate acid. This is the conjugate acid of ammonia. Si ammonia originally is NH3, tumanggap po siya ng hydrogen from acid. Acid donates hydrogen. Base accepts hydrogen, and it will produce a conjugate acid. In this case, acetate is our conjugate base. This is the conjugate base of acetic acid. The same thing. Acetic acid gives hydrogen for the base so that it will become a conjugate base. Take note, guys, that acid-base reaction is interchangeable. Okay? It can be the reaction can goes to the left, the reaction can goes to the right. In other words, ito pong conjugate acid natin, pwede niyang i-give off back the hydrogen to our conjugate base. O, tama pa din. Why? Kasi sabi natin, acid donates hydrogen. So pag dinonate niya yung hydrogen going back to our acetate ion, it will give you acetic acid, which is an acid. And this conjugate acid, ammonium ion, lose hydrogen for a conjugate base to give you your ammonia. Okay? So that is our conjugate base and conjugate acid. Please take note of that. Okay, so let me erase my writings on my whiteboard. Ngayon, okay, uulitin natin according to Bronsted and Lowry, acid donates proton. It will produce what? Conjugate base. Okay? A base accepts hydrogen. It will produce what? Conjugate acid. Okay? Now take note of this, guys. Take note of this. A strong acid, a strong acid produces a weak base. And a strong base produces weak acid. The other way around. The other way around. Strong acid produces weak, lagyan natin ng conjugate, weak conjugate base. A strong base produces a weak conjugate acid. Sabi natin, acid-base reaction according to Bronsted and Lowry is interchangeable. So, ibig sabihin, a weak conjugate base will produce a strong acid. A weak conjugate acid will produce a strong base. Like our example a while ago, we have our ammonia plus acetic acid. Si ammonia, weak base. Si acetic acid, weak acid. It will produce what? It will produce acetate. No? Acetic acid will produce acetate. And ammonium ion. Okay? Acetate ion is a strong conjugate base, and ammonium ion is strong conjugate acid. Okay? On our learning management system, meron po akong pinakita doon or meron po akong table doon ng acid and base conjugates. And I want you to take note of that. There is an inverse relationship between strong base and the conjugate it produces. Okay? And for example, hydroiodic acid. Okay? Hydroiodic acid is an example of a strong acid, but no, it produces a weak base, which is our iodide ion. Okay, so I want you to take note of this. Water can be acid and at the same time can be base. I repeat, acid can be considered as water can be considered as acid and at the same time can be considered as base. That will be depending on the reaction na meron siya. Okay? If water acts as acid, then that is considered as a weak acid. When water acts as base, that is considered at least somehow a strong weak base then. Weak base po si acid, si water as acid. I repeat, weak acid po si water if it will react as acid, and it is also a weak base if it will react as base. Okay, so take note, an acid can be a positively charged, neutral, or negatively charged. Let me delete this one. So, take note guys that acid can be positively charged, negatively charged, or neutral. Example, we have hydronium ion, a positively charged. Okay. We have phosphate, no? And we have carbonic. Now, for base is considered as or can be negatively charged or neutral. Yan lang siya. Si base can only be negatively charged or neutral. Okay? And acid is therefore classified as monoprotic, diprotic, and triprotic. Triprotic. Kapag monoprotic, it can only lose one hydrogen. Kapag diprotic, of course, 2 hydrogen. And 3 hydrogen. Okay? Example of monoprotic is our hydrochloric acid Example of diprotic is carbonic acid. Example of triprotic is our phosphoric acid. Okay, so that is our acids and bases according to Bronsted and Lowry. Ngayon, I want you to take note guys that carbonic acid, pasensya na sa mga manok para may background music tayo. No? I want you to take note guys that carbonic acid, okay, carbonic acid can give one proton to become bicarbonate ion. So our carbonic acid is CH2CO3 plus water. The reaction can be interchangeable. It will produce bicarbonate plus hydronium ion. And I want you to take note, and I want you to remember guys, that this bicarbonate, no, that this bicarbonate in reaction with water will give you, no, carbonate ion. This should be 3. Now, a carbonate ion, a negatively charged particle, plus, again, hydronium ion. Okay? That is for carbonic acid. Now, I've mentioned a while ago that water can be an acid and can be a base, depending on the reaction. And that is an example, or that term is what we call ampiprotic. No? Water is an example of what we call ampiprotic. What do we mean? This is one word. Ampiprotic. Yan. What do we mean by the word ampiprotic? It is a substance that can act as either an acid or as an base. Okay? And the last is a substance cannot be a Bronsted-Lowry unless it contains a hydrogen atom, but not all hydrogen atoms in most compounds can be given up. Okay? So let's have an example. Example is we have show how the ampiprotic ion hydrogen sulfate, that will be HSO4, can react as both acid and base. Okay? So meron daw po tayo ditong example, no? Show how the ampiprotic ion hydrogen sulfate can react as both an acid or as a base. So number 1, that will be HSO4 negative plus water will give us what? Okay, let's show it first as an acid. Okay, it will be an acid if hydrogen sulfate, I will use another color. It will be an acid if the hydrogen of hydrogen sulfate will be loose. to produce, to react with water to produce what? It will produce hydronium ion plus our sulfate. Okay? That is, in that case, this is an example of an acid reaction. Hydrogen sulfate ion reacts as an acid. Now, how about as a base? No? How about as a base? Hydrogen sulfate plus hydronium ion will give us what? This will give us water and sulfuric acid. Ano po yung nangyari? No? Ano po yung nangyari? Yung pong hydronium ion natin, nagbigay ng proton kay hydrogen sulfate ion. In that case, if hydronium ion gives proton, then this is our acid. And this is our base. Bakit? Siya yung nag-accept right? Siya yung nag-accept ng ating proton. So we have here water and sulfuric acid. In other words, the reaction between sulfuric acid and water will give us hydrogen sulfate ion and our hydronium ion. Now, how about for this one? HPO4 to negative. Let us show how hydrogen phosphate ion reacts as an acid or as an base. Okay, so acid muna tayo. As an acid, so we have here HPO4 to negative plus water will give us, correct, hydronium ion plus phosphate ion. This will become negative or 3 negative. Okay, so as a base, we have hydrogen phosphate ion plus water will give us what? So ito yung yung hydrogen phosphate natin yung base. Ito yung acid natin ngayon. Ano ginagawa ng acid? I'm sorry, hindi na pala siya kita. Ano yung ginagawa ng acid? Ang acid, nagbibigay ng hydrogen. So this will become H2 H2PO4. Nagbigay si water ng dalawang hydrogen. Ng isang hydrogen rather. Nagbigay si water which acts as an acid ng isang hydrogen to hydrogen phosphate ion to give you this one. And it produces what? Hydroxide. So that is the reaction, or that is how we are going to show acid-base or amphiprotic substances as an acid and base. Okay? Next is, take note that there is an inverse relationship between the strength of an acid and the strength of its conjugate base. So that is what we have discussed a while ago. A stronger acid, the stronger the acid, isusulat natin, the stronger the acid, the weaker conjugate base it will produce. Okay? The stronger the acid, the weaker conjugate base it will produce. And the other way around. The stronger base, the weaker the acid, the weaker conjugate acid it will produce. Right? So I will cut the discussion in this part, and the next part, the third part of our discussion will be all about acid-base equilibria.